started. Welcome to the 7th lecture.
Yes.
तो क्या किया हमने last time?
Even odd functions.
Right. So still working with signals. Yeah.
Yes.
So that was kind of the first module of the course. What was it? Signal basics. Right. एक पूरा module था. Yeah. So what did we do in the signal basics? Broader categories क्या हैं? क्या किया था?
How to work with functions, transform, like how to shift
Operations हो गए.
operations.
एक ये wider topic हमने किया, right? और
ठीक है.
classification. Right? So classification, operations, ये दो चीज़ें हैं main जो उसके अंदर हमने we covered. Even जो towards the end we did even odd signals. That was also classification. It's even odd or neither. Yeah. So अगर if I am to just sum it up, the first module was basically within it there were two parts: classification of signals and operations on signals. Right? फिर उन operations में क्या आया? That is for compression, shifting, right? Converse करना वो सारी चीज़ें. This was signal basics. Yeah. Now we are going to move to the second module of the course, which is on, as you would suspect, system. Title में भी यही है, right? So system basics. Yeah. And in here, just like the signals, we will start with classification. I've already told you why we want to classify, because that makes our job easy. Divide and conquer thing. You develop tools for the subclass, and then those tools can be used by anybody who can show that their problem fits in that subclass. Yes. So now of course systems, I've mentioned before. What is a system? हमने vocabulary में तो किया था थोड़ा सा.
So जो कि signal को move करने से.
Which
processes
a signal, and processing for us also includes generating or receiving. Yes. So क्या है इस रूम में क्या क्या systems है? Speaker system है, AC system है. What else? ये हो गया. तो ये कहा था इलेक्ट्रॉनिक और इलेक्ट्रिकल आप बता रहे हैं ना. अब उस डोमेन से निकल के और कोई बताएं सिस्टम इलेक्ट्रिकल इलेक्ट्रॉनिक्स के अलावा.
हवा ही ले लो आप. हवा से गुजरती है, एक एम्पलीट्यूड कम रहता है सिस्टम.
जो इस रूम में जो एटमॉस्फेयर है या ठीक है. व्हाट एल्स?
दीवार की एग्जांपल दी थी आपने एक दफ़ा.
राइट. तो एक्यूस्टिक सिस्टम की बात करें. सो एक्यूस्टिक सिस्टम है, अगर वो अच्छा ना हो तो एकोज बहुत होती हैं, हॉल इफेक्ट फील होता है. राइट. सो ये वुड लगाया हुआ है अच्छा इन्होंने पूरा वो. सो that is a system. What is this system? System definition क्या है? Processes the signal. Yeah. So this system, the acoustic system, is processing my voice. Right. आप तक जो reflections आ रही हैं किस तरह वो आती हैं. और कोई system? Electrical और इसके अलावा आप खुद भी सिस्टम है. राइट. सो आपके सेंसर्स हैं, ईयर्स हैं, सारा प्रोसेसिंग होती है ब्रेन के अंदर. राइट. सो इवन दिस मसल सिस्टम, दिस इज अ सिस्टम. राइट. ये मसल को इनपुट ये आप करते हैं तो मूव होता है. यस. सो दिस इज ए फिजियोलॉजिकल सिस्टम. या. सो सिस्टम्स आर एवरीवेयर and they can be in any form. Okay. Mostly जब हम सुनते हैं we think of electronic or electrical systems because there is where it started, the computer system, yes system. But system is everywhere. Even the system of running a department is a system. A country मुल्क का होता है ना system, निज़ाम जो होता है. Right. So that system is operating on signals which are our aspirations, our hopes, or what we want to do or what we are doing, how the system responds when we are sick, how the system responds when we need healthcare or education, right? So मॉनेटरी वाले में कौन सा सिस्टम होता है? मॉनेटरी टर्म्स में, पैसों की टर्म्स में
बैंक
इकोनॉमी होती है, बैंक है, दैट इज अ सिस्टम. इनपुट है, पैसे देते हैं आप लेके, राइट? स्टॉक एक्सचेंज ह्यूज सिस्टम है. सो
ऑक्शन भी सर एक लिहाज से
डबल शाह भी
ऑक्शन नहीं ऑक्शन है
ऑक्शन भी एक
डबल
सिस्टम
शाह
है.
एक वेलफेयर सिस्टम
आप
है.
एक वो करते हो कि हाँ भाई प्राइस रेस करते हो, आगे से वो कहता है कि इधर लॉक किया जाए, फिर एक और बंदा प्राइस रेस करता है.
लेकिन ऑप्शन अलग सिस्टम में आता है.
And then
सिस्टम ही तो है.
सिस्टम में क्या अलग
मनी लॉन्ड्रिंग भी सिस्टम है.
yeah. So now you get the idea. Yeah. Okay. Now with systems, of course, system can be something not even physical. Yeah. It could be an algorithm. Simple algorithm है कि whatever you write, I will write double of that. Simple. आप 4 लिखेंगे तो मैं 8 लिख दूंगा, आप 8 लिखेंगे मैं 16 लिख दूंगा. It's just an abstract algorithm. क्या purpose है वो हम बाद में देख सकते हैं. But that abstract algorithm itself is a system. Yeah. So a lot of digital processing we do is falls under that. वो abstract हो रहे होते हैं काम, right? So okay, as you said, everything, a lot of systems here. You have seen circuits वगैरह आप ले रहे हैं कोर्स?
ले रहे थे.
थे, हो गया सर्किट 2 भी हो गया. हो गया बड़े एडवांस हैं आप लोग. सर्किट 2 भी काफी, राइट? सो circuit, electrical circuits, basic circuits, they are systems, right? So you have this thing, and let's say at t equal to 0 you roll the switch, and then you have a resistor here, and you want to read what is the voltage here. Right, so this is a very basic electrical system. Right? This resistor when you throw the switch, it will receive, let's say there is some DC voltage here for convenience. It will receive some input, right? So that will be the signal going in. इस switch को close करने को हम already represent कर चुके हैं with what? कौन से सिग्नल या फंक्शन से represent किया हमने? Step. Impulse would be yeah. Yes. So this was, if you throw the switch, this is step. Before throwing the switch, there is no input here. Yeah. When you throw the switch, you get in an idealized world. Of course, reality में ये थोड़ा time लेके ऐसे जाएगा. But in an idealized situation, it's the step. Yes. It's not unit step. It will go to VDC. Scaled step है, whatever that VDC is. Okay. So now there are so many systems. How can we know their responses? That is a very difficult task, right? So I have said this before. In this course, we want to develop mathematics that is agnostic to the nature of the system. वो system electrical है? Is it electronic? Is it physiological? Is it acoustic? Is it monetary? Is it psychological? Or is it just an algorithm on a paper? हम उससे हमारे लिए वो meaningful नहीं है. We want to develop mathematics that can apply to all such things, right? Or that is the reason you see neural networks being used almost everywhere. They are abstractions हैं कुछ. So how can we classify systems? How can we understand their responses? And how can we model them? अब इतनी ज़्यादा variety है, right? So if you want to model a physiological system, आपको biology की और physics की समझ होनी चाहिए. Yeah? If you want to model a monetary system properly, आपको monetary systems की समझ होनी चाहिए. Acoustic system, you should know how voice travels, sound travels, what materials do to it, how light travels, all that. So that you can always do, as I've said before. You can try to do that, make lots of differential equations, and then get stuck with that. That is from the first principle, ab initio. Yeah. But here the mathematics we want to develop is going to make abstract versions of that. We don't want to go into that physics. We do go there in many cases, but in a wide variety of problems, we don't want to go there because we know it's going to be too complicated. Okay, so why not work, if we can, work with abstractions that are general and that can get the work done. Right? So that is what we will do in this part. We will get started by first classifying or trying to understand the response of systems. So let's say for us now, since we are not going to bother about the actual physics, biology or whatever field that system is coming from, we will treat the system as a black box. ठीक है? Black box, ये वो जहाज वाला नहीं है. Black box modeling is part of the signal system and neural networks and all that. It says that you don't care what the physics is in here. आप ढूंढ नहीं रहे अंदर कितने gear लगे हुए हैं, क्या कुछ है, right? You are only interested in seeing this system from its input and output. ठीक है? Only things you are interested in is if I give it this input, what output does it give me? I am not interested in writing the physics of this thing or the physiology or whatever biology of this thing. Yeah. So what we want to do is say, okay, if I probe this black box and let's say I give it an input x and say it gives me y. Let's say to get started. Right, we will call this the input and this is a response. Yeah, are they both signals?
Yes.
Yes. So systems का input और output signal होता है. Yeah. So this is our black box system, meaning we're not bothered or we're agnostic to its actual physics or science, whatever that is. Yeah. So there's an input. There's an output, fine. What are the questions we may ask about this system? Those questions would lead to classifications. Just like for the signal, we ask several questions. Here we will ask maybe 9 or 10 questions. Each question will lead to sub-classifications, right? So let's say this has an input x and an input y. Okay. Do you want to ask any question about it?
सर अगर ये एक एब्स्ट्रैक्ट सिस्टम है तो आप ये पूछ सकते हो कि इसका जो फंक्शन है वो एक्सपोनेंशियल है या लीनियर है.
Right. How will you find that out?
आउटपुट देखकर आपको डाटा चाहिए होगा.
मजीद इनपुट देते जाएंगे और
हाँ.
good. So you can ask many questions. Let me start with an easy one, but don't think that that's the only thing. Okay. One question we may want to ask is, what happens if I double the input? What happens if I double the input? Double shell के case में.
आउटपुट वही है, एक ही है.
Does it also double the output or not?
No, not in that.
करता है या नहीं?
Depend कर
So,
case पे depend करता है.
The answer is of course, in general, we don't know. Yeah, it might double it, it might not
Half
double
it. It might even half it.
It might half it. Yeah. So tax system होगा पूरा, double charge. Okay. So it may do those things, but the question is very natural. Makes sense. If I give it x, it gives me y. What if I give it double of that? Does it double the output or not? Now the system doesn't have to double it, but let's say it does. Whatever scaling I give here, that scaling shows up here. Okay. If I half this, this is also half. If I triple it, this is triple. If I alpha times x, it becomes alpha times x. What is that system? What would we call it? What is that behavior?
linear.
Homogeneous or homogeneous, however you want to pronounce it. A system that scales its output exactly as you scale the input is called homogeneous or homogeneous. Yeah? It is not bothered with what intensity you give it. अगर आप उसको डबल करेंगे ये भी डबल कर देंगे, ठीक. So now we are already classifying the systems. Now we said systems don't have to do exactly that scaling, but the systems that follow this will be called homogeneous systems. And systems that don't follow this, let's say you give 2x and it gives you 3y, yeah, that will be non-homogeneous. Yeah. Okay. So that was one question. What was the question? Does scaling the input scale the output by the same amount? Yes, by the same factor. If it does, yes, it is homogeneous. If it doesn't, it's not. What else can we ask? So we could ask, let's say, what happens if I add, so let's say I give x1 signal to the system and it gives me y1 output, and I give x2 some other input to the same system and it gives me y2. My question is, okay, what if I send this system a sum of x1 and x2? Then what is its output? Superposition, yeah. So does the system give me a simple sum of the original outputs? I gave it x1, it gave me y1. I gave it x2, it gave me y2. Now I'm giving it a sum of the inputs. Does it also sum the outputs accordingly or not?
System पे depend.
Now again, yes, system doesn't have to do it. But the class of system that does that are systems that allow superposition. Okay, and if it does that, then the output y, let's say new y, is y1 plus y2. So if you sum the inputs, the outputs are summed. Okay, now that kind of system we will call, in this case, we'll first start with this one. It's an additive system. Okay, so first one was homogeneous. This one allows additivity. Okay, again, there are additive systems and there are non-additive systems. What would a non-additive system do in this case? It will give you something other than y1 plus y2. Maybe it gives you 2y1 plus y2, anything. Yeah, it won't give you y1 plus y2, something else. Yeah, and this property has to hold for any x and x1 and x2. ये नहीं है कि कोई एक आपने टेस्ट किया और उस पे वो सम आ गया, you say it's additive. This has to hold in general. Yeah, so then we'll call the system additive. Now what happens if we combine these two properties? What if a system is both additive and homogeneous? Then let's say we have a, basically then we are saying I give it the sum of these two. Yeah, remember the assumption is that when I gave it x1 it gave me y1, when I gave it x2 it gave me y2. What happens if I give them the sum but scaled? Now we are combining the two properties, scaling plus addition. Yeah, what if it still preserves everything? The output is simply the same scaling of the first output plus the same scaling of the second output. Yeah, notice this is not possible unless the system is both homogeneous and additive. Yeah, now if the system does that, then we say this system allows superposition. Alone additivity without the scaling is not superposition. Yeah, so and these systems, आपने किसी ने पहले नाम लिया था, these are linear. Okay, a system that allows superposition is called a linear system. Okay, linear. Now we are usually not interested too much in just homogeneous or additivity alone. It's the combined thing that we are interested in, whether it allows superposition or not. And this is a huge classification. Pure fields, structure, and I can tell you, linear system is an undergraduate topic, non-linear system is a graduate topic. Or each one itself is a huge field, right? So we come to the first big classification of systems. There are linear systems and there are non-linear systems. Okay. In this course, we stay here in the class of linear systems. Now, is that restrictive? Is that a problem? Firstly, from learning point of view, it makes sense to work with a subclass. We will see that this subclass is much easier to handle, firstly. Secondly, आपने linear non-linear function पढ़े होंगे calculus वगैरह में, right?
सर आपने इस तरह क्यों ड्रॉ किया है कि linear सब non-linear के अंदर आ रहा है जैसे?
नहीं अंदर नहीं आ रहा, ये systems है ना, right? So this is the whole thing is systems. आप अगर उसको hash कर लेते हैं तो ये part non-linear है, right? और वो linear है, yes. So linear will be inside non-linear if I write non-linear here. वो तो उस section को मैंने बस show किया है, तो बस hash वगैरह लगा लें तो फिर easier हो जाएगा. The whole thing is system, and inside it two subclasses, right? So as I was saying, just like for linear and non-linear functions, the things you study for linear functions you can often apply to non-linear functions locally, right? Piecewise आप apply करते हैं. Same thing here. The topics we study in linear or the solutions we study in linear can often be extended for non-linear problems, but in a localized way. छोटे छोटे आप chunks पे you consider them linear for short ranges and apply theory of linear there. Yeah. Then you can also develop new theory and has been developed for non-linear systems. But still, one of the most popular ways to handle non-linear system is through linear. आप जो functions को जो study करते हैं, जो आप slope निकालते जाते हैं, वो क्या होती है? आप जगह उसकी छोटी सी आप linear line लगा रहे होते हैं, ऐसे ही है ना? Function को जो आप draw करते हैं. So you are non-linear function है, but locally you are making small lines, yeah. So same, almost same thing here, and it's heavily used in non-linear systems. So why am I telling you that? Because the fact that we'll be restricting ourselves to linear system does not limit the application or use of what we will learn. Okay, it's very useful still in here. Yeah, highly non-linear system वहाँ पे मुश्किल हो जाएगी. So we develop new tools, but then again, how many systems are highly non-linear? वो फिर देखना पड़ेगा. And a wide class of problems that we deal with are actually linear or almost linear. So this is a useful thing. So first major class क्या आ गई? Linear versus non-linear. What's the difference? Linear system allows superposition. What is superposition mathematically?
Addition.
Yes, it's a combination of homogeneity and additivity. दोनों मिला के आते हैं. Scaling leads to same scaling. Addition leads to same addition. Yes, दो parts होते हैं इसके, right? And this is what we call a linear system. Okay. और कोई सवाल पूछ रहे हैं हम? Let's bring in time. अभी हमने time को नहीं लाया इसमें ना. क्या करें? So let's say we have a system. If you give it xt, it gives you yt. Again, this guy black box. Don't care. कहाँ से आया? Physical world क्या है इसकी? Okay. So let's say this. So one question we may ask is, what happens if I shift the input? So let's say I give it an input, which is a step function. Let's say at some time. Let's put it capital T. Okay, and the output I get, let's say, is shaped like a triangle, just for showing purpose. So this is xt, this is yt. I'd say that when I gave it this input, I got this output. Yeah, let's say this is at t1 and this one was at t2. Fine. Now, one question I may want to ask is, what happens if I shift my input? Maybe I give it earlier than before, यानी थोड़ा सा t1 left को चला जाए. If it was 3 seconds, I start it at 1 second maybe, or I give it a bit later. Fine. What happens if I shift my input in time? So let's say I shift it to the right t1 plus some small amount tau. Now I am giving the input a bit later. I shifted the input. What happens to the output? That is one question we may ask. Yeah, if I shift the input, is the output shifted equally or accordingly or not? So in general क्या होगा? Again, just like linear systems have no obligation to do that, right? But the systems that follow this, that is, if you shift the input by a certain amount, then the only change that appears in the system is that it is also shifted by the same amount. The rest of the shape, height, everything remains exactly the same. Yeah, so a shift in the input results in a equal shift in the output. Nothing else changes. Then we call this system, क्या कहेंगे इसको? कोई पता? Time invariant. Invariant क्या होता है? Not varying. Time invariant, not varying with time. Its behavior does not change with time, in the sense that if you give an input at t1, it gives you this output. If you shift the input, the only change that occurs is shift in the output. Yeah. Otherwise, its behavior remains the same. Okay. So humans are time invariant or time varying systems?
Time variant.
वेरिएंट है. एक दोस्त को छोटी सी बात कहे, आप मूड अच्छा है, वो हंस देगा. फिर किसी और टाइम पे कहे मूड अच्छा नहीं, वही बात कहे आप. सेम इनपुट एट अ डिफरेंट टाइम, डिफरेंट आउटपुट आएगा ना. हाईली टाइम वेरिंग है humans. Yeah, so this is just an easy example to see. So what is time invariant? The only change in the system that should happen is equal amount of shift, nothing else. अगर एक time varying system है ना, let's say a system is time varying and you just shift the input, its output may change its shape. Yeah, this would be a time varying system, or its output may still look like a triangle but may not be t2 plus tau, maybe some other shift. Still it's not time invariant. Okay, because now it's not shifting by the same amount. And as you will see, non-time invariant systems could behave so much differently depending on when you give them the input, even if your input is exactly the same. Okay, this is an important property, because then if we are planning for those systems, we should not only know what input to give them, we should also know when not to give that input. Right? दोस्त का मूड अच्छा नहीं है तो उस वक्त वो same joke अच्छा आइडिया नहीं है. Right? So because you want to get, why do we study systems and signals? क्यों study करते हैं?
ताकि predict कर सकें.
Predict कर सकें, that's one thing. Yeah.
सर किसी चीज़ की रिप्रेजेंटेशन हमें
ठीक है.
पता लगा
कंट्रोल कर सकें उसे, उसके बिहेवियर को, आउटपुट को एडजस्ट कर सकें अपने बेनिफिट में. Yes, whatever we want to achieve from that. Yeah. So if you don't understand its, उसका मिजाज आपको नहीं समझ के, सेम इनपुट है, जो आपकी मैंने यूनिट स्टेप दिया था जल गया. राइट, वो डिपेंड करता हो कि उस वक्त टेम्परेचर क्या था रूम का. ऐसे सिस्टम्स भी हैं which are very sensitive to the temperature or something. Yeah. So you have to see is your system time invariant. So this is now the second classification, major classification. पहली क्या थी? Linear versus non-linear. उसके अंदर फिर वो homogeneous और additivity शामिल हो गए थे, लेकिन we just talk about linear non-linear. This is the second major classification. There are systems that are time invariant and there are systems that are time variant, and together they are the full class of systems, right? So as you would guess, we will work with in this course time invariant systems. Yeah, now we are also working with linear subclass. So together this course is LTI, linear time invariant system. ये term आप बहुत ज़्यादा सुनेंगे, acronym LTI. Yeah, linear time invariant. Linear means allows superposition, right? K1 x1 plus K2 x2 equals K1 y1 plus K2 y2. Time invariant means that when you shift the input, the only change that occurs in the output is an equal amount of shift. That's it. Nothing else changes. Yeah, that is time invariant system, and we'll come back to all of these. अभी तो मैं सिर्फ classification बता रहा हूँ. Later we will go through systems. We'll try to classify them, develop mathematical formulation to test them correctly. But anyway, now we are in the subclass of LTI systems. Yeah, so there are LTV systems. Now, just like linear and non-linear, in time invariant and time variant, the tools you learn here can often be used here, because you can consider many systems to be locally for a short period of time. Okay? हो सकता है assist time over 1 minute is very time varying, उसका behavior बहुत time varying है, but over seconds it might be assumed almost time invariant. तो ये होता है. Okay? So then the tools you develop can be used here, then here piecewise use होते हैं. So it works fine, कोई उसमें इतना issue नहीं. And then you can also develop tools directly for time varying system. वो भी होते रहते हैं. So but at this level in this course we are going to stick to the subclass LTI, linear time invariant. Okay, any other questions we can ask? Questions तो बहुत से हम पूछ सकते हैं ना.
सभी जो क्या कहते हैं असाइनमेंट में सवाल पूछे गए थे.
हाँ वो
Causal है.
हाँ एग्जैक्ट. चलिए अच्छा है ना, आपको प्रीव्यू मिल गया ना.
Invertible.
आप लोगों ने असाइनमेंट कर कैसे लिया?
सर मैंने पूरा नेट से देखा था, तुक्के मार के लिख दिया.
चले इसीलिए मैंने वो एक्सटेंड कर दिया ना. पहले मुझे पता चल क्या था, मैं एक्सटेंड क्या नहीं किया, यानी कि आपकी फिर क्विज की तैयारी भी रह जाएगी, राइट. सो ज़्यादातर सवाल तो वो उन टॉपिक से थे जिस पे क्विज था ना. राइट. सो another question we may ask. So पहला question क्या हो गया? Does it allow superposition or not? If it does, it's linear. Yeah. Second question, does its behavior change with time, actual which time you give the input? If it doesn't, it's time invariant. दो question, दो classes. Third question, we might be interested in asking, okay, does the systems, let's say this is the system and I don't know what the output is, but let's say the output is xt, or it is some function of xt and xt plus minus some tau. Tau not equals 0. Now I might be interested in asking, is the output a function of the current input only, or does the output depend on the current input and the past or future values of the input also? Okay. So if I want to, or if a system follows this thing, what is it? The output at time t depends only at the input at time t. So y5 is depends only on x5, nothing else. Not on x4. What was the value of this signal at one instant before, one instant after? This system doesn't care. If it doesn't care, we're not saying every system will do that. Yeah, but if a system depends only on the current value of, this is saying it's a function of the current value. What function it is, square, sine, whatever, वो हम नहीं कह रहे अभी. We're just saying it's a function. And if it is a function of the current and past or future, yes, already अब वो पढ़े थे ना operation, time shifting वगैरह, they are already coming into play. Scaling is coming into play. All that वो इसीलिए हम करते हैं that we want to use these things. Yeah. So if it depends on past or future values also, then firstly if it does not depend on any of these things, किसी को पता है इसका क्या नाम होगा?
Causal.
वो आगे आएगा. ठीक है, वो भी है. अभी memory less. Okay, why memory less? इसको कोई आगे पीछे की कोई वैल्यू इसको नहीं पता. It just cares about the current value, right? So we call these memory less systems, and this is called memory system.
memory pool.
ठीक है? So a memory less system is what? Which depends only on the current value or of the input. और इसको हम instantaneous system भी कहते हैं. Another name, same thing. Instantaneous, why? That it bothers about the current instant. बाकी इसको आगे पीछे कोई परवाह नहीं है. ठीक? अब क्या अलार्म लगे हुए, क्या चीज़ है? वैसा है कोई?
उठते इस टाइम.
उठने का टाइम हो गया. चलो उठ जाए जो सो रहे हैं क्लास में, वो तो उठ जाए. Right. So this is a subclass, memory systems versus memory less systems, और memory systems का भी एक नाम है. So the other name for memory less is instantaneous, and the other name for memory system is dynamic. Okay, dynamic systems, and this is a memory or the another name for memory. So for example, can you tell me if I give xt and the output I get is 4xt plus x squared t? Is this a memory system or a memory less system?
memory system.
Memory full
memory
dynamic.
सिर्फ XP पे
So
depend.
ये memory less system
Yes, yes, yes.
So क्या है? Memory less है. Yeah. What about this guy? Let's say
पहले से बता रहा हूँ.
पहले से बता रहे, अब मैं चेंज कर देता हूँ.
अब memory.
x square t plus 1 memory system हो गया. Just showing you what this means. Here we didn't say what function it is, so क्योंकि हम generic रखना चाह रहे थे. Yeah, all we bothered was about whether it's current or others are there. ठीक है? चलिए, let's do one more and then we will stop. Further classifications अभी काफ़ी सारी हैं. तो कितनी हो गई अभी classifications? काफ़ी हो गई. वैसे ये आप कहेंगे तो आप लेक्चर खत्म कर देंगे, लेकिन किसी ने नहीं बोला इसलिए कंटिन्यू. एक कर लेते हैं ना. लेकिन कितनी होगी? 3 हुई है. लीनियर, टाइम इनवेरिएंट वगैरह और मेमोरी वर्सेस मेमोरी लेस. एक थर्ड कर लेते, फोर्थ कर लेते हैं, देन वी स्टॉप. सो वी माइट बी इंटरेस्टेड इन आस्किंग, ओके, जो आपने अभी कहा भी है कॉजल का. सो कॉजैलिटी क्या होती है वैसे?
Causation.
ठीक है, नहीं वैसे क्या? What is causality in physics?
सर एक चीज की वजह से दूसरी चीज हो रही हो.
Casual.
वो तो cause करना हो गया ना. But the concept of causality. It is said that causality is probably the most fundamental part of nature. Okay? मतलब फिजिक्स का ये वो कॉन्सेप्ट है जो इट इज़ बिलीव्ड, क्योंकि अभी मुश्किल है सेम, इट्स नेवर वायलेटेड. क्या है कॉजैलिटी?
कुदरत का निज़ाम. एक लिहाज से.
राइट, तर्जुमा. राइट. तो आपको कॉज का पता है और इफेक्ट का पता है. ठीक है, क्या ऑर्डर होता है इनका?
कॉज पहले आता है, बाद में आता है.
ये कॉजैलिटी है. Causality is that effect can never come before the cause. ठीक है? It is considered to be the most sacred law of the universe that we know so far. कभी इसकी violation नजर नहीं आती. ठीक? So effect cannot appear before the cause, that is called causality. Yeah. So in our terms, causality applies something similarly. A causal system. So if a system depends only, or let's say, if a system does not depend on a future value, if its output does not depend on a future value, we say it is causal. So it depends on the current and the past values only, right? Now if it depends on a future value, its output depends on a future value, let's say here the output, as long as the output depends on xt and past value would be xt minus something, yeah, some past value, yeah, it depends on that. Or if it depends, this would be for us now causal, yeah. But as soon as a future value shows up, the current one can be there, past ones can be there, but as soon as a future value shows up, it becomes non-causal.
So इसमें
Yeah.
plus some future values को specify करते हैं.
इस case में we are saying the output at 3 depends on x3, x let's say 2 and x4. उस तरह आप इसको read करिए ना. So let's see very quickly how this looks. Causality. So let's say you have to tell me is this system causal or not.
Future
Yeah.
input पर पुराना output.
नहीं होगा.
नहीं होगा. So yt, the output is twice xt plus 4xt plus 1.
Sir ये causal नहीं.
Non-causal है.
Is non-causal
No.
because to get the output at t, let's say t is 5, you need x
Future value
6, yeah,
Future value.
future value not there, yeah. So this system is non-causal, okay. And why study non-causal system? ये पहले भी आगे किसी कॉलेज में पूछा था, so we discussed that. क्या वजह हो सकती है? Future value तो
डाटा पहले से हो आपके पास.
yes. So one reason is, you might say, okay, let's just drop this because it's never going to happen, yeah. But it could be that you have already recorded all the data. For example, let's say you have collected x at t1, x at t2, x at t3, and so on, let's say tn. And your system, the system you have, is basically an algorithm that says that yt1 at any given time t, it is the average of the three values like this. Let's say the output yt1 is xt1 plus xt2 plus xt. Now this, the way you write this algorithm, it will appear as non-causal. The only thing it will tell you is that there is no way you are going to implement this in real time. Live नहीं हो पाएगा. होते हैं algorithm ऐसे बहुत सारे हैं. आपकी image processing में बहुत सारे हैं. So, but it tells you have to buffer the data. कितना data buffer करना है वो उसकी memory पे है. तो इसलिए you need a memory. It has to be a memory system. You need to start recording the data, buffer कर लें 3 points, फिर उस पे output निकालें. फिर 3 point buffer कर लें. So yt2 will be xt2 plus xt3 plus xt4 divided by 3. Yeah. So this algorithm is using future values. Current भी use कर रहा है और आगे future के भी. But it can only be done this way. What other reason could there be?
Future values क्या कौन सी वाली है जो कि use हो रही है?
Again, to give the output at for t1, yes. So you want to use जो भी आपको यहाँ से 3 values चाहिए, yes. Let's say this is a voice signal, it's pre-recorded ठीक है. Now you want to generate a slightly smoothed version of this, yeah, and you would like it to be less, let's say, rough, a slightly smooth version. One simple way of making this smooth, so this is the input now, this is what the output you want it to be. One simple smoothing filter being used in image processing, in audio processing, is that you say, okay, this point yt will be an average of, let's say, 5 points before and 5 points after. Okay, so the output or the new signal at this time is using values that were originally after this point. Yeah, this you will not be able to do unless you have recorded this beforehand, right? Otherwise it's not possible. So that is what we mean by future values. और क्या हो सकता है? Let's say लाइव करना है हमने, कैसे कर सकते हैं?
वही बफरिंग कह लो, बहुत हल्का सा डिले
वो तो फिर आ गई ना, मेमोरी आ गई, लाइव तो नहीं रहा. Precisely live नहीं रहा. So non-causal systems can still be there with this. उसमें एक थोड़ा सा trick है बस. If you remember, I said when we started writing the signals that we will write it xt. The x-axis will be t. But I said it doesn't have to be time, right? It could be space. So it could be representing the roughness of this table along distance. Yeah, so the t could be these values. Okay? If the independent parameter is not actually time, and there are signals जिसमें वो time नहीं होता. Yeah, the temperature across some place at a given time वो spatial होता है. Yes, number of students attending classes also. In many situations, the independent parameter is not time. It might be, let's say, it is the temperature along this rod. Yeah. Now the temperature along this rod, if you record it, you may want to write it as XL1, XL2, XL3 at these lengths, not T. Even though we write T as general, but the signals we are working with don't have to be made of time. Yeah. Now the temperatures, if you record them here, if it's a non-homogeneous kind of rod, इसकी composition कहीं alloy कोई और है, कहीं कोई और alloy impurities add हुई हैं, so its temperature may vary. This is a signal, yes, but this is not a signal which is function of time. It's a function of space. Yeah. So in that case, causality won't be violated, even if you use, let's say, you want to say my yL1 is xL1 plus xL2 divided by 2. Yeah. Now it looks like you are using a future value xL2, but since L, the independent parameter, was never time, कुछ और था ये, इस केस में space था, so it may look like it's non-causal, but it can still be implemented because the independent parameter was never time, or something else. वो time में मसला है. So non-causal developments still are useful in many situations. Yeah. So we will see that. We'll do some more classifications next time. और फिर हम आगे चलते हैं. Any questions?
शुरू हो गई हमारी दूसरी